All right, we've already mentioned it in the previous lecture, but it's worth recording here formally, which is the Poisson approximation to the binomial distribution, sometimes also called the law of rare events. So we haven't talked about it in this course yet, but you're probably heard of the law of large numbers. And one way to think of the law of large numbers is as the law of frequent events, or the law of not so rare events. And the law, this is called the law of rare events, is where the Poisson distribution comes into play. And it's also sometimes called the law of small numbers. So law of small numbers, meaning if we're expecting a small number of things to happen out of a large number of possible ways it could happen, let's say, then the Poisson distribution is a good approximation. So the way that we say this is that suppose that we have a random variable y, binomial, and p, and let's say that x is Poisson with parameter n times p. When is x approximately equal in distribution to y? So at what point is this true, and at what point does this approximation hold? And this is what the law of large numbers says. The law of rare events says is that if n is large, p is small, and n times p is moderate in size, then y is approximately Poisson n times p. And another way to look at this, another way to think about this is the probability mass function probability that y is equal to, well, another way to formalize this is that as n goes to infinity, p goes to 0, such that n times p converges to some value mu positive and finite, so strictly between 0 and infinity, then the probability that y equals k, which initially starts out as the binomial probability, n choose k, 1 minus p to the n minus k, converges to the Poisson probability, mu to the k to the minus mu over k factorial. So that's the law of rare events. That's how we would use the Poisson distribution to approximate the binomial distribution. And next, we're going to show another very nice and important property of the Poisson distribution called the reproductive property.